Okay, question 6. The shortest distance between the lines. Okay, these two lines. Now, in order to find shortest distance, if they ask for shortest distance between lines, you must definitely suspect, or rather more or less confirm, that the lines are parallel. Because if their lines are not parallel, there are only two possibilities. One, they intersect. If they intersect, then there is no distance to talk about. Then they wouldn't ask you, actually. Quite dumb. Okay? Quite dumb. Or the shortest distance between two skew lines. Okay? The shortest distance between two skew lines. Maybe the lines are skewed, there is a shortest distance. Did I cover that in lecture? No, I didn't, because actually it's not in syllabus. Okay? Shortest distance, this is distance between two skew lines, not in syllabus. So unlikely, or rather it's not possible, that they will ask you that. Okay? So that one is gone. So definitely these two lines are parallel. Okay, these two lines are parallel. And I don't really like the way this thing is presented. I like to write it like that. 1 minus 1, 0, plus mu, 3 minus 2, 6, where mu belonging to real. Okay, and the other line is r equals to 2, 1 minus 3 plus lambda minus 6, 4 minus 12, where lambda belonging to real. Now, so by observation, it's not difficult to see that the direction vectors are parallel. Yes, so therefore these two lines are parallel. So if you recall, I said in the summary, distance between two parallel lines, shortest distance between two parallel lines, is the same idea, exactly the same idea, okay, as finding the shortest distance between a point on one line and the line. So if you get the shortest distance between point and line, yes, then you will get it. So this point, what point can this be? There are so many possibilities, but the most convenient one is the one that is provided 1 minus 1, 0. So now actually this thing is reduced to this problem. It is reduced to finding shortest distance between 1 minus 1, 0 and this line. Correct? Draw your arc. Yes, it is reduced to finding shortest distance 1 minus 1, 0 to this line. So how do you find shortest distance between this thing and this line? I take another point on the line. Of course, in this case, it's easy to take 2, 1 minus 3. Yes. And the direction vector is, would I write minus 6 for minus 12? I wouldn't. I just use the same direction vector as the above line, like that. Yes, this one is parallel to this one. Doesn't matter, because eventually you know, if you are clear enough, you know eventually you're going to use unit vector. Yes, eventually you're going to use unit vector. So let's call this A, let's call this B. Yes, so all I want is shortest distance, this one, I call this F. I want to project AB onto, no, I want to use AB cross unit vector of the direction vector. Yes, cross, because the way you remember is this side is the opposite side. When it's opposite side, it is a sine theta, therefore it's cross product. Recall your projection diagram all the time. Yes, so you will use shortest distance equals to AB cross unit vector of this one, which is 1 over square root 3 square plus 2 square plus 6 square of 3 minus 2, 6. Which is AB is what? AB is OB minus OA. Yes, OB minus OA, which is 1, 2 minus 3. Yes, cross 1 over 7, 3 minus 2, 6. Therefore, you cross already, you will get 1 over 7. Now practice your cross product now. Okay, practice. Okay, testing. Okay, you can cross. Pause a while. If you want to do it on your own, practice. You will get a 6 minus 15 and minus 8. You may want to pause the video for a while just to make sure that you really get how to do the cross product, just as a practice. Therefore, you get 1 over 7. Okay, you do magnitude. You get square roots of 325. Alright, therefore you simplify, you get 5 root 13 over 7. Why is this 5 root 13? This thing is 25 times 13. Okay, just to explain, 25 times 13. Okay, 325 is 25 times 13. You factorize 25, you get root 5. Okay, yep. That's that. The question actually didn't ask for exact form, so actually you can actually 3SF it also. 3SF it as well. That is not a problem. Yes? Okay? Thanks.